Okay, so let's go over the safety precautions when it comes to sealing in your home. This is a really important section. I like to think of this issue as you don't know what you don't know. And so I'm going to be going over things that you should know to look into to see if you have a problem in your home when it comes to sealing it in. So let's get started. The first section I want to go over is backdrafting. So backdrafting is caused by an air pressure imbalance. Now when you seal in your home, well, let's talk about regular homes. When you have a traditional home, it breathes, right? You have random cracks in your home, maybe it's not insulated very well. It's allowed to breathe, it's allowed to regulate its pressure, okay? So in an ideal home, you'd want to have a balanced pressure. And what that means is that the pressure inside of your home is the same as the pressure outside of your home. And when you have this balance of pressure, you aren't going to have issues with things like backdrafting, okay? When you have a sealed home, oh, let's not go there yet. When you have a sealed home, you're taking away your home's ability to regulate its pressure. So you're going to have to do that manually, and you're going to have to monitor some things in your home that can be affected by a pressure imbalance, which of course we're talking about backdrafting, right? So that's kind of one of the things that is affected when you have an air pressure imbalance. Okay, so in energy efficient retrofits, it's found that 10% of these retrofits have combustion appliances that create dangerous levels of carbon monoxide. And of course, carbon monoxide is, the silent killer. It's tasteless, odorless. You can't see it with the naked eye. You really don't know that you have an issue until you're either showing symptoms of an issue or, unfortunately, you hear on the news of families that have perished overnight due to this. So it's really, really important that you are aware that this could be an issue when you seal in your home. Now, there have been 500 deaths per year related to non-fire-related CO poisoning, carbon monoxide poisoning in the United States. So this 500 number, that occurs when you have things like combustion appliances or fireplaces, when you have backdraft of those fumes into your home. I'm going to go over the physics of that. Let's just finish this slide. So there's 15,000, that's the number of emergency room visits per year related to non-fire related CO poisoning in the United States. So these people, they've showed symptoms, right? They're vomiting, they have migraines, they don't know what's going on. They go to the ER to see what's been going on, find out they have CO poisoning, and that is the only way they really knew that they had a CO issue in their home. Okay, so this is really dangerous, but there are things you can do to make sure that your family's safe, especially when you seal in your home. Okay, so let's go over exactly how it works. So here we have a properly sealed home, right? So the red line represents a sealed building envelope. This dotted line here represents a gap in that envelope. And this, of course, is a chimney. Okay, we got a fireplace right here. So what happens is your fire burns. It's taking in the air from the room that it's in. It burns the fire. It creates byproduct, creates CO. But that gets exhausted out of your home, okay? And this happens in a balanced system, balanced pressure system. All of those exhausts get out of your home and you don't have any of the toxins inside of your house, okay? What ends up happening is that you develop a negative pressure in your home. And this happens various ways, but you get a negative pressure in your home, you have a positive pressure outside your home. And due to the law of physics, everything wants to reach an equilibrium, okay? So your house is going to try to match the pressure inside of its home to the pressure outside of your home, okay? So you have a balanced system. So the way it's going to do this, since your entire building envelope is sealed, is that it's going to try to rush through, the air is going to try to rush through any gap you have in your building envelope. And in this situation, the gap in the building envelope is going to be this chimney, unfortunately. So what you have going on is this fire is making the byproduct. It's going to try to, to come out, but due to the fact that you have a draft coming down here, because it's trying to reach an equilibrium, a pressure equilibrium, it's going to backdraft all of these toxins in your smoke, and you got your carbon monoxide. It's going to backdraft all of that into your house. Okay, so this is what backdraft is, and this is why it's so dangerous. Is because it's basically poisoning everyone in your home. Okay, now that's the first scenario I wanted to go over. The second one here which I think it relates more to more people since not all of us have fireplaces in our home, is people that have atmospheric gas burning appliances, which a lot of us do have in our house. So how this works, how these atmospheric combustion appliances work, is that they pull air from the room that they're in. Okay, so this air comes in and it fuels the fire, and it goes through complete combustion as long as there's enough oxygen in the room. It undergoes a complete combustion, and because heat rises, it leaves the home through the exhaust flue. But let's go over a scenario where you have a sealed home. So this red line again represents your sealed home. The dotted line represents the gap in your building envelope. So what happens is the air from this sealed room, or technically sealed home is how this would really be in reality, but we're pretending this is a room. Sealed room, the oxygen is being pulled, or the air is being pulled in here. There's plenty of oxygen to fuel the fire. It undergoes a complete combustion, and then it leaves the conditioned space through the flue. All right. So what ends up happening is that at some point you're going to run out of oxygen, or you're not going to have enough oxygen. Okay, so it's going to continue to pull the air from this room, but since there isn't a supply to this room, it's going to provide air to the fire that doesn't have enough oxygen. And what happens is that it undergoes an incomplete combustion. And when this happens, you end up creating more carbon monoxide than you should. It's just going to create an excess amount of carbon monoxide. And fortunately, in this situation, it's going to get exhausted out through the flue. Okay? But the problem with this is that at some point, you're going to create a negative pressure because you're pulling the air outside of this room into here, and it's getting exhausted out. You're now creating a negative pressure situation inside of your conditioned space. Okay? So here we go. Now you have a negative pressure inside of your conditioned space. You're going to have a positive pressure outside the conditioned space. And due to the law of physics, it's going to try to reach an equilibrium, just like in the last scenario. So you're going to have a draft of air coming through this exhaust flue. It's going to come right through the appliance, and it's going to backdraft all of this exhaust into your home. Okay, it's the same situation as it was before. This is really deadly. This is what causes people to, go to sleep and never wake up. This is very important to keep in mind, okay? So what can you do? All right, there's plenty of things you can do. First of all, you can get your appliances inspected. There are things, like you can see visually that you have a backdrafting issue. In my city, our utility company does free inspections. So check to see if your utility company will provide something like that. They just come out, they check all of your things. They'll check your wall, your furnace, your water heater, things like that, to make sure everything's working properly. And the solution. So let's say you do have an issue, or maybe you just want to get rid of your appliances so you don't have to deal with anything like that. What you can do is switch to all electric appliances. And this makes sense if you're eventually going to want to make your home powered 100% with renewable energy. So if you're putting solar panels on your roof, or you're installing some wind turbine, something like that, I would definitely recommend switching everything to electric, so that at some point down the line you can have your entire home run 100% on renewable energy. If that's not something you want to do, if you still want to use gas burning appliances in your home, then I would switch to a sealed combustion appliance. So the difference with this appliance, the one we just saw, the last one was an atmospheric combustion appliance, and what that was is that it pulls air from the room that it's in. A sealed combustion appliance, it pulls air from outside of your home, right? So you're supplying an outside source of air to fuel that flame, right? So that it can go through complete combustion. And what that happens with this appliance, there's no real air exchange within your home. So even if there is backdrafting, it's just going to backdraft air outside of your home. And to be honest, you shouldn't get backdrafting, since there isn't going to be any type of pressure difference, because you're pulling air in from the outside and it's being exhausted from the outside. There shouldn't be any issues with backdrafting. But if there is something, if your appliance is malfunctioning, if it's producing too much CO, it's not going to backdraft into your home. It's going to be backdrafted outside. Okay, so let's say you are in a situation where you don't want to get rid of your combustion appliance. What you can do is move that combustion appliance into a non-conditioned space. So conditioned space is anything within your building envelope. It's the air that you're breathing. So everywhere in the conditioned space essentially is all shared air. So if you pull your combustion appliance out of your conditioned space and you can move it into something like the garage, I would recommend not sealing in your garage with your home, just keeping that as outside your building envelope. That's because your car is going to create exhaust. Generally you have a lot of chemicals in the garage. You have paints, things that can off-gas a lot of chemicals, and you're not going to want to share your breathing air with those things. So I'd recommend not having your garage within your conditioned space and pulling all of your appliances out there. So if there is an issue with backdraft, it's just going to backdraft CO into your garage, and you're not going to have an issue where you're breathing in excess chemicals from that backdraft. Of course, if you find that you have an issue with those those appliances causing backdraft, I would definitely get that remediated, but it's just not going to bring your family, leave your family in immediate danger if you do have backdraft. Okay, and lastly, the fireplace issue. My personal opinion is that fireplaces don't have a place in these energy efficient homes. Fireplaces, they just aren't energy efficient whatsoever. Additionally, it's really hard to seal them in, and it's a really complicated scenario. You could put a air sealed glass plate on the front side of your fireplace. There's no air exchange between the fire and your room, but then you're going to have to supply some kind of fresh air to supply the fire so it can go through a complete combustion and everything get exhausted out. There shouldn't be an issue with pressure difference if you're bringing in the air from the outside. Since the air is coming from the outside and it's being exhausted at the outside, it all shares the same pressure. So those are your two options with fireplaces. I personally would just stop using your fireplace, seal it up, maybe it look nice and pretty, or just get rid of it completely. And so yeah, that concludes the backdrafting section. So let's move to the next section.